Good evening, Arun. Welcome. Good evening, everyone, guys. All right. Please confirm if you can hear me properly. Okay. Very, very good evening, all of you. Yes, all of your friends are joining in, guys. Let's wait for everyone. All right. So everyone can hear me properly. Please once confirm. Good evening, all. All right, guys. So in this series, in the reaction mechanism series, in the previous session, we have already discussed some really, really important examples of reactions, right? तो आज भी हम वही करने वाले हैं. With respect to stereochemistry, we are going to discuss some really important examples, right? चलो. So let's move onwards, guys. And there are going to be more sessions consecutively, and I'm aiming to have a almost daily practice session on YouTube. Okay, and for regular updates, guys, please join the Telegram group CSIR NET 2022, because here I will be putting up all the links, all the important links for all of you to join up on time. Yes. All right, everyone is here very well. Very good evening, all of you. Chalo. So, what are we discussing today? Reaction mechanism में we have already discussed a lot of examples while we were studying in the plus classes. Here we are not discussing everything in detail, but we are just discussing some really important examples. जैसे कि आज देखते हैं example number 1. Based on this reaction, for example, ये देखो, there is a molecule like this. It is orthoxylene molecule. ठीक है? Right. Now, if I am providing bromine to it in the presence of AlCl3, you know that this is going to undergo bromination. Yes, right? Let's say I'm providing excess of bromine to this molecule. So, with the Lewis acid catalyst, it is going to do bromination. But where is the bromination taking place? तो आपको पता है guys, bromination is going to take place on the benzene ring. What is going to be the position? Both of the methyls are having orthopara directing property. So let's say that the bromine, being bigger in size, goes to the para position, one of the bromine like this. And then once again we are adding one more bromine that is going to be added once again to the para position. Okay, so ये क्यों बनाया हमने? To avoid the steric hindrance. This is what you are getting. Okay, now the same molecule, if we are providing bromine in the presence of light. First example this. Second is, if to the same molecule we are providing NBS in the presence of AIBN. आज ही मैंने ये question कराया in the special class. ठीक है? And discussing this is really, really important, guys, because NBS will also give you an electrophilic bromine as well as a radical bromine depending on the situation. So in the presence of light or in the presence of AIBN, it will give you a bromine radical. Same over here. Both of these are going to give you radicals. Alright, तो इसलिए ये इतना ज़्यादा important है कि हमें अब ये क्या देने वाला है. This molecule is not going to give you simple bromination. It gives you CH2Br, CH2Br like this. साइड चेन के अंदर रिएक्शन हुआ है. ओके, so the side chain of the benzene molecule has actually reacted. This is very, very important. Side chain has reacted. इसको हम बोलेंगे benzylic bromination. benzylic bromination. Okay. Yes, so this is the selectivity of bromination, whether it is going to take place or on the ring or on the side chain, depending on the conditions. ठीक है. तो guys ये देखो ये कौन सा reaction है. We are comparing two reactions over here. One is a electrophilic aromatic substitution and the other one is simply radical reaction. Okay. So we will consider more examples of electrophilic aromatic substitution. ये भी reaction mechanism में है, बहुत important topic है. Let's consider example number 2. All right. All right, guys. Now look at this molecule. Position of groups matter a lot in the electrophilic aromatic substitution. Let's look at this. That is, let's say you are having this molecule. Okay. So this molecule is going to give you this product. I am telling you the reactant as well as the product. Okay. And if you are having any problem, you can message in the live chat. Yes. तो ये वाला जो reactant है, it is giving you this product very well in this condition, reaction condition. So reaction number B, like this, it is going to give you in the presence of aldehyde as well as HCl. It is also going to give you. Alright, so basically यहाँ पे एक ऐसा ही कुछ product बनना चाहिए था, isn't it? Should have formed something like this. Should have formed something like the same in this way, but this molecule is not forming. This is forming and this is not forming. Any specific reason that you can think of? What is so important about it? And what is the reason, specific reason that you can think of over here? कि ये first वाला molecule तो बन रहा है, लेकिन second वाला नहीं बन रहा है. Yes, everyone. What is the selectivity? And why is the selectivity? Any idea? No idea. Yes, electrification. What's your name? Okay, you. All right. Chalo. So how is it happening? First of all, guys, yes, देखो, the first one is forming, the second product is not forming. तो ये बहुत important है. छोटी छोटी चीजें हैं, little things that can be asked in a question. That is, you look over here in this molecule. If I'm adding RCHO to a amine, what will happen? That is, if you are adding an aldehyde to an amine, first of all, let's write it over here. First वाले molecule में add कर दिया है. Alright, so how is it going to be? The amine is first of all going to give you iminium ion, yes or no? Right? It is going to give the imine first of all. Now this imine is going to be attacked by one of the positions, right? ये देखो, it is going to be attacked by one of the positions onto this particular carbon and the bond opens up to nitrogen. Alright, so this is how cyclization will take place onto this particular carbon. इस वाले carbon पे cyclization तभी होगा when you are getting the assistance of the para methoxy. Yes or no? Because ये वाला जो methoxy है इससे कोई फर्क नहीं पड़ेगा. Look at the structures, guys. Let's say this is NH positive. Now this is NH neutral. Okay. Yes. Yes, guys. There is time in Diwali. पहले क्वेश्चन देख लेते हैं. मैं अभी बहुत दिन क्लास लेने वाली हूँ. दिवाली में टाइम है. हम लोग धनतेरस को भी क्लास करने वाले हैं. So don't worry. Yes. आ जाओ. So what are we discussing? देखो, ये जो methoxy है ना, it is present on the meta position as compared to the group which is being added. The group is being added over here, the aldehyde यहाँ से add हो रहा है, but ये तो meta position पे है. So meta position पे if you are having a methoxy or whatever group, that doesn't matter, because यहाँ से क्या हो रहा है, इसका कोई contribution नहीं है. No contribution of this meta methoxy. Contribution is done from either ortho or para position. Ortho पे कोई नहीं है, para पे है. So all right, contribution is done from the para position. All right, so this is what you see in this way. Only the para-methoxy is going to help. So if only the para-methoxy is going to help and there is no contribution of meta-methoxy group, इसीलिए ये product बन रहा है. And here if there is no contribution, resonance नहीं है, so you are going to get back the reactant because nobody is assisting in the reaction, isn't it? That is why you don't get this as a major product. Second reaction में वापस से starting material मिल जाएगा. Okay? Yes. Yes, इसमें कोई reaction नहीं होगी second में. Alright, so you understood, guys, what is important. Now this is very simple things that we are discussing, because these little things are forgotten when we are giving the examination. That's why we are discussing it right now. Alright. Example number 3. Once again, talking about aromatic electrophilic substitution only. Now there are two things. There are two more very good examples that we want to discuss. One is, let's say you are having a bromine you're having bromobenzene. Okay, and in this molecule I am adding AlCl3. So guys, this particular molecule, it gives us this product. Okay. Example number 3, this molecule bromobenzene on addition with this kind of a molecule, देखो क्या है ये, dihalo compound है, in the presence of Lewis acid will give you a complete cyclization product. However, if I just take the same molecule or any other molecule irrespective of that, and I have taken a di, let's say I have taken a diacyl molecule, कभी कभी ये diacyl भी बोल सकते हैं इसको, or let's say if I have taken a anhydride molecule. Alright, I have taken an anhydride molecule with AlCl3. That is only going to give me one single reaction. Okay, let's consider the second possibility. That is only going to give me one single reaction, let's say over here, only one acylation. It is O minus या फिर OH after the aqueous workup. Yes, what do you get? Why do you have this? इनको बिल्कुल नोट्स में ऐड करना है. These examples are directly from the books and these classes are equally important for the plus students as well as the non-subscribers, क्योंकि ये वाले हम एग्जाम्पल दोबारा रिपीट नहीं करेंगे. That is why they are important. Yes, Shubhankar, definitely. Thank you. All right. So the reason behind it? Yes, the reason behind it being that is this is bromobenzene. You are having AlCl3 over here. That is going to push away the Cl minus. You will generate a carbocation over here. So this carbocation is being attacked. ठीक है? Ultimately ये देखो ये कार्बोकेटायन है यहाँ पे. द कार्बोकेटायन इज गोइंग टू बी अटैक्ड लाइक दिस. फ्रॉम विच पोजीशन? फर्स्ट फ्रॉम द पैरा पोजीशन. तो पहले तो पैरा पे अटैक करेगा. आप तो बोलोगे मैम ये मेटा क्यों आया? why is this meta coming over here? But first attack is going to be first electrophilic aromatic substitution from the para position, and next time when you are having one more carbocation possibility, because there is one more AlCl3 over here trying to pick away the Cl minus from here. ठीक है, अब होगा because there is a cyclization which has to take place. Now the meta attack has to take place. Okay, yes. No, Arun, these are all mixed examples. Okay, so now you are going to get the cyclization twice. Okay, so in the presence of AlCl3, just the Cl minus had to be removed and the ring is ready to attack the carbocation. Very well. So that is why double cyclization, double reaction is taking place. What about this, guys? इसमें ऐसा क्यों नहीं हो रहा है? In the anhydride, if you are taking the anhydride, why you only get a single acylation? Why not double? Because let's say in the presence of AlCl3, one of the bond is going to open up. When one of the bond opens up, you are going to get the acyl cation like this. Oxygen पे positive. Let's say ये यहाँ से attach हो रहा है in this way. 1, 2, 3, 4. So 1, 2 and 3 and 4. O minus AlCl3 like this. ठीक है? Alright. Now the bromination is only going to take place from this carbon, because अभी एक bromination होने के बाद में product कैसा दिखेगा? O minus AlCl3. Right. So after one reaction, see the proton is going to be lost over here. Alright, because there was a carbocation like this, so proton will be lost. So bromine is the orthopara directing group, not a problem. That is why you get first reaction on the para position. लेकिन अब एक बार reaction हो जाता है guys, when the reaction is done, you are going to get a molecule like this. You are getting the benzene again, but after that on the other side, you are getting a carboxylate, O minus AlCl3. Okay, like this. And this is not going to be facing another attack from the ring because it is itself negative. ये खुद ही negative entity है, इतनी ज़्यादा negative है, electron rich है, so that it does not want another electron density from benzene. It will do the repulsion. इसीलिए complete reaction नहीं होता है. So be careful about what is being asked. Okay. Now we do few more examples, guys. बहुत अच्छे अच्छे example है हमारे पास में. Now we have done plenty of examples of electrophilic aromatic substitution. Now we want to try out some really good example of fragmentation. अभी इसके बाद हम करेंगे fragmentation. And also guys, once again I am reminding all of you that today is the last date. आज 18th of October है, and today is the last date for subscribing to Unacademy Plus for free. 7 days free trial you are getting by scanning this QR code. The QR code is already given to you in the Telegram group. आपको क्या करना है, कैमरा से सीधा स्कैन करना है, ओके एंड वहां जाके रजिस्टर करना है. स्कैन करके जो लिंक ओपन होगा, जस्ट रजिस्टर एंड सिलेक्ट CSIR NET as your goal. Activate your code and you can use the educator code Jagriti S Live. और फिर आपको बस पढ़ाई शुरू करनी है. For the next 7 days you are having all the Unacademy Plus features for free. You can check it out. So please join up guys, take the use of benefit of all of these things. और एक और चीज गाइज, 30th of October को you are having another all India live scholarship test, which is going to actually help you in getting an Academy Plus subscription within as much less as possible. Okay. Yes, तो जिनको भी Unacademy Plus subscription लेना है, and for those who are studying by themselves, they can wait for 30th of October. नहीं तो आप अभी वो start कर दो free वाला, ठीक है. And although for those who want to study full-fledged, start करना है, wait नहीं करना है, you can join up using the code Jagriti S Live and just enroll in this batch. It is the batch going on right now. All right, elementary detail batch. Chalo. Now guys, we have to discuss some really important examples of one more type of reaction, that is fragmentation. And for fragmentation I have always emphasized guys, मैंने आपको बोला भी था कि आप chapter number 36 पढ़ो क्लेडन का. Have you studied that? Have you opened that chapter? Tell me first, yes or no. Chapter number 36. Yes, yes everyone. All right. So if you have done it already, तो आपको थोड़ा बहुत idea है about fragmentation. Yes, yes, very good. Then we are going to move onwards and we are going to discuss some of the examples of fragmentation. Okay, very simple examples. ठीक है, पहले इसको देखते हैं, एक मॉलिक्यूल को. Example 1. Yes, very good all of you. Very good. See, what do you see over here? One is an OH group, the other one is a OMS. OMS, OTS, OTF, all of these are good leaving groups. ठीक है, ये सारे good leaving groups हैं. So first I am providing a base and the second step is I am providing acid for the workup. Alright, so base के presence में क्या हो रहा है guys? First of all, there is a base that you are having. Base is, let's say I'm writing B minus. It could be anything, it's not mentioned. So B minus is going to take with the most acidic proton. वो कौन सा है? OH का है. OH proton is the most acidic, and then what? The OH bond is going to open up. But from where? If the bond opens up like this and the molecule wants to create a double bond O over here, तो उसको एक bond और open करना पड़ेगा, either this or this or this. तो फिर ये वाला जो bond है, इसको open करके, because you are having a good leaving group mesylate over here, that is why you can open it up. And I'm writing the molecule as it is. ये हो गया carbonyl. Next is one double bond over here. This is how the molecule is going to look like. Alright, so this is how the molecule is looking like. So इसका जो product है, it is going to look like this. On the fourth position, you have the allylic group. इसको बोलते हैं allylic group on the fourth position. So this is a simple fragmentation reaction. Yes or no? Okay, इसको क्या बोलते हैं guys? What do we call this? We call this push-pull fragmentation. Okay, we call this push-pull fragmentation. Okay, the OH proton is removed and the mesylate is a leaving group. So OH O minus is pushing the electron और mesylate उसको लेके चला जा रहा है. That is why we call it a push-pull fragmentation. Okay. Now what is next? Let's see. This example is clear to everyone. आगे चलें. चलो तो. Example number 2. Now look at these two molecules. This is a 7-8 membered ring, right? This is a 8-membered ring that you have got. Also, the junction is trans. The above hydrogen is below and the lower hydrogen is above. All right. If we are reacting this first molecule, then you get this molecule. And if you are reacting the second one, then also you get the same molecule under same conditions. Okay, and there is no oxygen over here. This is just one carbon. ठीक है? Yes. अब देखो, there are two molecules, 1 and 2. Both of these molecules are going to give you the same reaction, the same product, this product under this condition. चलो guys, बनाने की कोशिश करो. Try to make the reaction. Try to do the mechanism by yourself and tell me what's going on. What is the first step? What is the first step of this reaction? देखो OH minus है. Obviously, it is not directly going to attack the carbonyl. It is first going to attack the acetate. उससे क्या होगा? O minus will become free. So इसके लिए check करते हैं guys. ऐसे. ठीक है? Alright guys, अब आ गया time fragmentation का. So O minus is going to fall over here and ये देखो, there's a carbonyl, so this bond is going to open up. Right? Since there is a carbonyl, the bond can open up and do fragmentation like this. Okay, if it was not a double bond, single bond hota, तो oxygen must be a good leaving group. Otherwise, oxygen is not going to help in fragmentation. ठीक है? Yes. So the ring opens up. You are getting some of the intermediate like this. ये 7-membered, 8-membered ring हो चुका है. It's an 8-membered ring. All right. Let's say this is your carbonyl. इसको बाहर लिख देते हैं. Ring is expanded from over here, and this ring will be as it is. All right, this is the as it is ring. अभी आपको पता है it is going to do the tautomerism. This part, this carbonyl and the alkene, this is going to do tautomerism and finally gives you this molecule. That is one on the second position, one on the 1, 2, 3, third position with respect to this ring. Okay, not a problem. What about over here? Yes, the second molecule. Once again, you have the acetate that is going to give you. Once again, that gives you O minus. और हमारे पास वही चीज है. We are going to just break this bond, this central bond we are breaking and we are breaking it into the carbonyl. क्योंकि carbonyl में अगर break हुआ तो it is going to do resonance, isn't it? It is going to form an enolate like intermediate and the rest of the ring is still 8 membered. Okay, and you are going to have the ring like this. Because ये 5 membered ring तो ऐसे के ऐसे ही रहेगी ना, ये वाला bond open up हुआ है. So the 4 membered ring opens up. This is what you get. And also, yes, there is O minus which is fallen over here. This is carbonyl. अच्छा ये double bond नहीं है, single bond है, ठीक है? So this is what you are going to have. अभी ये tautomerism करेगा. After tautomerism, it is going to give you back the same molecule. So when we are doing fragmentation, it is not necessary कि एक ही मॉलिक्यूल एक ही तरीके से फ्रैगमेंट करता है. द मॉलिक्यूल कैन फ्रैगमेंट अ लिटिल बिट इन अ डिफरेंट मैनर in the under the same condition. There are two different molecules which are actually isomers of each other. These molecules are just isomers of each other, same number of carbon and hydrogen. They are going to give you the same enolate, okay, the same reaction of fragmentation, right? अब हम लोग बात करेंगे गाइज एक और लास्ट एग्जाम्पल की विच इज एक्चुअली अ लिटिल बिट ट्विस्टेड, ठीक है, बट थोड़ा सा ट्रिकी है, बट इट इज रियली रियली हेल्पफुल. ये देखो, यू मस्ट लुक एट द वन विच इज गोइंग टू ब्रेक द रिंग और कौन लीविंग ग्रुप है, दोनों को चेक करना है. ये देखो 165 डिग्री सेंटीग्रेड. हाउ इज इट गोइंग टू फ्रैगमेंट? Yes. How is it going to fragment? Once again, I will mention over here. ये देखो. See, it is already COO minus, मतलब कि कहाँ से फ्रैगमेंट कराना है, दैट यू हैव टू चेक. COO माइनस से अगर ब्रेक डाउन करेंगे, सो इज इट गोइंग टू लीव टू द बॉन्ड विच इज हैविंग OTS. इसको हटाना है यहाँ से. सो इज द COO माइनस गोइंग टू हेल्प? नो. हु इज गोइंग टू हेल्प? द लोन पेयर ऑफ ऑक्सीजन. ठीक है, ऑक्सीजन का लोन पेयर भी इसी डायरेक्शन में है. So lone pair of oxygen is going to help and the OTS is going to leave. Alright, ये देखो, this is the motion. Now what do you do? This central bond is going to break. तो हमें क्या करना पड़ेगा? Alright, so this is your oxygen. इसको ऐसे कैसे लिख देते हैं guys? Because here we have to write a double bond. Alright. Yes, and the oxygen will have a positive charge. Let's write it in the cyclohexane conformation manner. ऐसे डबल बॉन्ड लिख देते हैं पहले. And once again one positive charge on this oxygen, ऐसे लिखते हैं इसको. Positive charge on this oxygen. This oxygen will be as it is and the rest of the molecule will be as it is. This is what I was writing. COO minus will be as it is, ठीक है, और यहाँ पे हो गया ये methyl. Now what is this stereochemistry? always going to be checked in this way, the stereochemistry of the molecule. कैसे डिसाइड करेंगे कि कौन सा ग्रुप जा रहा है? देखो, OTS is a good leaving group, so look for a good leaving group within the molecule. And good leaving के साथ साथ में somebody who is going to push away the electron density at a 5 or 6 bond distance. अभी देखो ये ऑक्सीजन का लोन पेयर है ना, so 1 2 3 4 और ये लोन पेयर itself 5. so 5 bond बोलो या फिर 5 atoms के difference में you are going to get somebody who is going to push and somebody who is going to pull the electrons ऐसे difference में. okay, that is how you will identify कि fragmentation हो रहा है. all right, now what is next guys? अभी ये oxygen पे positive charge है, oxygen still has a positive charge over here. so what will happen is guys, yes, what will happen is अब ये जो COO minus है ना, all right, let's see once. all right guys, let's write it like this, COO minus. ये क्या करेगा? minus charge, it can fall back on the carbon and this carbon carbon bond is going to break over here and then this double bond opens up on the oxygen. so मतलब कि क्या बचेगा? alright, this bond has opened up already. so see guys, I'm just roughly writing the molecule, obviously अच्छे से लिखेंगे हम इसको, ठीक है? ये हो गया एक internal double bond obtained, right? so this is how the molecule is going to look like. और अच्छे से लिखना है तो ये देखो, this is the whole molecule. all right, you can just count the number of double bonds and the number of electrons. ठीक है, ये हो गया है इसका आंसर आफ्टर फ्रैगमेंटेशन. so this was a little bit tricky because यहाँ कौन कर रहा है fragmentation? lone pair is pushing over the electron density to cause the fragmentation. ठीक है, कौन कौन push कर सकता है? any other molecule or let's say a atom with a lone pair with a negative charge, the one which can easily lose a proton, क्योंकि हमें तो negative electron density चाहिए यहाँ पे for the pushing effect. pushing and the leaving group is pulling, ठीक है, and that is going to lead to several bond cleavage also. ये होता है fragmentation reaction. it is simple but it is tricky once again. okay, तो अब आपका क्या काम है guys? just go through Claydon chapter number 37 and 38 guys for radicals and carbenes. वो आपको check करना है based on the reactive intermediate and reaction mechanism. there are chapters from 20 to 25. वो आपको check करने हैं along with that. okay, and once again informing you all guys, for those who have not yet enrolled into this into this test, please do and take the maximum benefit of the free trial as well. I am going to see you all in another such session of reaction mechanism series very very soon. ठीक है, तो ये भी हम करने वाले हैं guys. okay, so I'll keep on telling you in the telegram group जो भी हमारा session होगा. I'll just keep on sending you the link and everything. I'll keep you updated guys. तो बस आप अभी पढ़ाई शुरू कर दो, practice शुरू कर दो and definitely we'll have a lot of sessions. so yes, take care all of you and I'm going to see you all in another such video. Bye everyone, have a good night.